Hi, welcome to the Shiko Math Practice Lab, Learning Through Practicing. This is our second practice set for the unit derivative rules and the formulas. In this video, we're going to talk about one very specific rule. We call it is the product rule. Okay, so before we go into the worksheets, let's take a look at what type of the problems we are going to cover in this video. So the first things here, we're going to just basically talk about what is a product rule looks like, okay? And then as the previous one also, the previous video, we have 6 very mechanical type of the problems. So basically, we give you the functions, and then you just use the product rule to find the derivative. And then for the problem number 7 and the problem 8 is kind of like the similar like the problem before, and we just kind of give you a function and then give you some given value, and then you want to find the derivative of this function. So it's still, you will need to use the product rule concept to do that. Okay, so the number 9 is back to the tangent line again, right? So we said for first video, we talk a lot about the tangent line. And then the last one, this one is very interesting, the problem. So instead of giving you the function value, they give you the graph here. And I think this one is quite useful. So so the number 10, that's what is our last problem for this practice set. Okay, so now let's go back to the worksheets so that we can start to work those problems here, all right? Okay, so this is the worksheets here. Okay, so like in here, the first things here we're going to talk about is the product rule, okay? So the product rules here, let's take a look here. So that means you want to take the derivative for both like fx times gx. So let me color it, so like color code it, all right? So the f of x is green, gx is yellow. So what is the product rules here? You cannot just take the derivative f prime times gx, okay? So the first things here, the product rule is like you hold the first one, not change, just the f of x. Then you take the derivative of the second function. Then after that, you hold the second function, not the change, see here. Then you take the derivative of the first function. That's what we talk about, the product rule. A lot of students, they're not careful, they will say the f of x, so sometimes they will say, oh, this is just be the f prime x times gx, right, g prime x. And then no, absolutely is not, right? So do not make this mistake. It will be, you hold the first one, now change, take derivative of the second one, and hold the second one, now change, hold the derivative of the first one. Okay, so let's take a look, the problems here. So let's take a look at our first set. And when I do this type of the problem, first I always kind of like, to show student, I always say, okay, let's try to color that, right? So here we say, hey, I have two values, two functions here, so 3x squared minus 5x and ex, right? Okay, so let's take a look. So the f prime x, you hold one still. So I'm holding the first one, 3x squared minus 5x, not changed, right? So you're holding this one, not change. And then you this one 2 times the derivative of the second one. So what is derivative of ex? Will just be the ex by itself, correct? Okay, now you're holding the second one, not the change is here. So this is you're holding the second one, not the change. And then you take the derivative of the first one. So the first one is 3x squared minus 5x. So you use power rule. So you move the 2 down. So what happened here? So this will give you what? 6x minus what? Minus 5. That's right. So that's what is the product rules, right? You hold one still, take the derivative of other, then hold another one still, take the derivative of the other ones here, right? So it doesn't matter which one you hold first. Right? So as long as you take, they take terms here. So in here, if you want, you can combine a little bit, and so this will be the EX. You can factor the EX out. So this is 3x squared minus 5x plus 6x minus 5. And then you can simplify, this will be the EX. So what is this? Is 3x squared plus x minus 5. Okay. Okay, now let's take a look at the second one here. The second one is gx is equal to, the x plus 2 square roots of x. So let's highlight again. So let's color coded it. Maybe we'll make the problems a little easier. I feel typical is pretty easier to see. Okay, so hold the first one. So not change the first one. Right, so not change the first one. Then take the derivative of the second one, ex. Well, I love ex, right? Because the derivative of ex will be itself, right? Okay, now then hold the second one. So that means you hold the second one, not change. And then you take the derivative of the first one. Okay, so here you need to be a little careful, right? So x is 1. So what is this? This is 2, the x what here is 1/2, right? So you use the power rule, it will be 1 plus 2 times what? 1/2. Now what is the exponent will be? Will be 1/2 minus 1 will give you negative 1/2. All right. Okay, so now in here, if you like, you can combine, factor the EX out also. Then the first one here is this is x plus 2 square roots of the x. And then this one here is a plus 1, then plus 2 and 1/2 is 1. So plus x to the what? Negative 1/2. Right? Or if you want to write it out, this will be x plus 2 square roots of x plus 1 plus, this is just put it in the denominators, right? Okay, so now let's take a look at the third one. So did you see here? That's why I said the first 6 problems are always very mechanical type of problems, right? You just want to apply it into the formula. Okay, so let's try to do again. So this is my first function, and this is my second function. So it's a product of the two functions. Okay, so what I need to do, hold the first ones, right? So hold the first one, okay? So not change anything. Then take the derivative of the second one. So the second one, be careful, this one's here, this is a p times p to the 1/2, right? So what is this one going to be? P to the 3/2. Okay, so now let's take the derivative. So p will be 1. Then what happened to the 3/2? It will be the 3/2. Then the p will be 3/2 minus 1. So what is the 3/2 minus 1? Will become 1/2, correct? Okay, and then now I am fixing the what? Second one, p plus p, the square roots of the p's, right? So this is the second one I'm fixed here. Then you take the derivative of the first one. So it's EP, well, still by itself. So it's EP's here. So the E, I really like this E functions. Okay, so now you can factor the EP out and try to simplify this a little bit. So this is a 3/2 p to the 1/2 plus p, and the p, the square roots of the p here. Okay, so that's it. It's pretty easy, right? Okay, so now, but it takes practice to get very good at it and fast at it, right? Okay, so let's take a look at this one. See here, you have 1 minus EZ, that's my first function, and the Z plus EZ, that's my second function here. Okay, so let's try to do it one more time. See here. So F prime Z, hold the first one, 1 minus EZ. Right, so 1 minus EZ, now moving, not change, and then take the derivative of the second one. So Z is 1, EZ, what is EZ? Hey, that's the one we love, is by itself, is EZ's, right? Then plus, holding the second one, right? So that's why I color coded that, so it makes me easy to see, right? Hold the second one and take a derivative of the first one. So 1 minus z, 1 will become to 0, so ez by itself, but don't forget this is a negative sign, so you have negative ez here. Okay, so most of the teacher might want you to simplify a little bit, so let's FOIL this out. So this is 1 plus ez and the minus ez and the minus ez the squares, right? So it's e2z, then minus z ez, then minus, right? So ez squared, so the e to the 2z. All right, and so combine the similar term. Oh, this is negative, this is positive, right? So combine the similar term, and these two terms are similar, right? So these two terms are similar. So my final answer will be 1 minus z ez. How many this e to z? 2e to z here. All right. Okay. So now let's take a look at number 5 here. So the number 5, the symbol, we have these ones here, and I have these ones here, right? Okay, so let's do it one more time here. So the y prime will be what? The y prime will be, hold the first ones, right? So it's z squared plus ez, hold the first one, not change, all right? Then take the derivative of the second one. So remember, what is z square root? So this is 1/2. So how do you take the derivative? It's 1/2. Then z. So 1/2 minus 1 is what? Negative 1/2, right? Okay. Okay, now you plus, I don't have a space, I don't want to invent it to go into that side here. Or maybe that's fine. So hold the second one. So hold the square root of the z, not change here, right? Holding this one. And then times the derivative of the first one. So z squared, what is z squared here? This will be 2z and plus ez, right? Ez, the derivative will just be itself here. That's it, all right? So now, if you want, we can simplify it a little bit. Like I said, most of the calculus will, afterward, apply the formula, then it's just your algebra skill, right? So sometimes your teacher just wants you to, to do a little bit more algebra things there. Okay, so now let's take a look at the FOIL here, right? So let's take a look at the FOILs here, and so will be the z squared plus ez and the times negative positive half of z to the negative 1/2 here. Okay, so that's simple. So this will be 1/2, right? So z to the square times z to the negative 1/2. What is here? Z to the 3/2, right? Then the second term is here. This just will be 1/2, right? Ez. So ez is on the top. I can put the square roots on the bottom. So I said it like z's here, right? So then plus here, so z and 2z. So what is this one here? Is 2z to the what? 3/2, right? Okay, so 2z to the 3/2. And then this ones here will be square roots of the z and the ez's here, okay? So these two terms are the similar terms. So let's try to combine it. So this one will be 1/2 plus 2 is how many? It's a 5/2 z to the 3/2, then plus, and then the ez's here, you can factor that out, right? So ez here, you factor that out, that's what just the square root of z plus 1/2 square root of the z's here, okay? All right, so let's take a look at the number 6 here. So let's do the same thing. Highlight the first function and highlight the second function here. All right, so let's try to do it. So what is the first one here? So j prime v will be holding the first one. So it's v3 minus 2v, and then take the derivative of the second one. Okay, so what is the second one here? So it's -4, right? So this one will be -4. So this will be -5 v to the -5. And then here, this will be plus -2, so become -2 v to the -3, right? Okay, so this is the one you're holding, the first one. And now I need to add, I hold the second one. So it's -4 plus v to the -2. So that means I'm holding the second one, now change. And take the derivative of the first one. So what is the first one here? Is 3v squared minus what? -2 here, right? Okay, so now, I think your teacher probably will want you to simplify a little bit. Okay, so now let's try to, FOIL it. So v3 times -5v2, so this will be the -5 what? So this will be v3 times -5, so this is a v to the -2, right? And the FOIL here, this will be negative. So this is a v -3, this is a +3, so this will be -2. And negative is a positive, so it's a 10 to the v to the -4. Negative is positive, it's plus 4v to the negative what? -2. Okay, so now I need to FOIL the bottom ones here. So -4, so this will be 3v to the -2, then minus 2v to the -4, then plus, so positive, negative, so it's a 3, then minus 2v, -2, right? So the minus 2v, -2 here. So let's see anything I can combine here. Okay, so I do have some good things to combine, right? So the -2, let's see I hope so -2, -2, -2, -2. All right, so the -2, -2, -2, so it's a 7, and it's -7. Oh, it's a cancel. Okay, so the negative, and here, so the -4, I have, how many -4s here? I have 10 and -2, so I have here, so this will be 1 minus 8v to the -4 here, okay, and so let me double check. Oh, I made a mistake here. That's why it doesn't match out. Okay, so here I made a mistake. So it's a silly mistake. So here, that's why something, okay, so this is a 4. Oh boy, all right. Okay, so if this is a 4, so this is a 4. Okay, so this is a 4. Okay, so let's see here. Okay, so here, I need to be careful, just like I say, you guys know how to do that, just need to be careful. So this is a 4, so this is -4 v to the -2, right? So you do like this, and then -2, good. Then minus here, that is another mistake. So this is a minus, is positive, so positive a to the 4. All right, positive a to the 4, and plus negative, so it's a plus. So here is a plus 4 to the v to the -2. Phew, okay, so now let's take a look at the bottom. So it's 3, so 3 Okay, so this is 3 times v to the negative 2, and then negative 2v4, then this will be plus 3 minus. Okay, so far so good. All right. Okay, so now let's find the similar term to combine. All right, so the similar term, we have v to the negative 2. So, oh, here is good, here is good, and oh boy, that's good. Okay, finally, all right, so it's like, so I have 1 v to the negative 2, then the constant here. All right, so that's getting better. So constants, I have 1, negative 2, 1 is a positive 3, so I have a 1. Then for the V4, I have 8 and negative 2. I got it. So it's a 6V to the negative 4. All right. Okay, so let's have to combine. This is what is the answer. So you need to be careful. Don't make a silly algebra mistake, right? Okay, so now let's take a look at the next ones here. So you say if f of x equal to the ex times gx, g0 equal to g prime 0 is 5, find f prime. Okay, so these ones here, basically they say, okay, I'm gonna find the f prime x. Okay, so this is, just like we said, this is my first function, and this is my second function. So what I need to do here, hold the first function, right? So hold the first function, then take the derivative of the second function, it's g prime x. Then hold the second function, so hold the gx, and then take the derivative of my first function, is the ex itself here. So this is a holding here, and this is a holding here, right? Okay, now I want to find f prime 0, so I'm just saying f prime 0, so that means x equal to 0, right? So I'm going to have E0, right? So I'm going to have E0, G prime 0 plus G0, E0. Okay, G prime 0 is 5. Okay, so this will be 5, G prime 0, and then G0 is 2, so it's 2, so the answer is 7. Yeah. Okay, now, okay, let's take a look at number 8. So the number 8 in here, they already give you the first derivative, right? So they want to find the second derivative. That means I need to take the derivative again. So the second derivative will be, so in here, still is a product rule because I have the multiplication of the two functions. Right, so now let's take a look at the second derivative. Hold the first one, so hold this x squared, then take the derivative of the second one, f prime x, right? So this is holding the first one. Okay, so now you hold the second one, so you're holding the f of x here. Then you take the derivative of the first one. So what is the first one? Is 2x here, right? Okay, so now you want to find f double prime 2. So you say f double prime 2. So this will be 2 to the square, f prime 2, then plus f of the 2 times 2 times 2. Okay, we have the f prime 2. Okay, so the only things we need to know is f prime 2. So the f prime 2, it will be equal to the 2 to the square, then f of 2, right? Based on these definitions here. So this will be 4. F2 is what? Is 10, so it's 40. Okay, it's good. So this one I have 4 times 40 plus F2 is what? Is 10, right? 10 times 4. So it's 160 plus 40. So what I have here, 200. Yeah, got that. That's the correct answer. Okay, now let's take a look at the last two problems here. Okay, so this one's here said gx equal to x f of 3. And now, in here, I want to find the equation of the tangent line for which function? For g at x equal to 3, right? So that means First, I need to know for g, x equal to 3, what is my g3? That's my point, right? So it will be 3 times f of 3. So what is my point here? So it's 3 times f of 3 is what? F of 3 is, the f of the 3 is 4, right? So it's 3 times 4, so it's 12. Okay, so my point is 3 and 12. So in order to find a line, I need a slope. So we did that in the first video. Well, what is the slope? It's a derivative. Okay, so let's take a look. Gx is equal to the f of x, that's right? Okay, so two function x and f. So, okay, take the derivative. G prime x holding the first one, that's right? So holding the first one. Take the derivative of the second one, so it's f prime x. Then hold the second one, right? So holding the second one. So if you color coding, you will not forget about that. Take the derivative of first one. So what is x here? X is 1, right? Okay, now I need to find the slope. So I need to find the g prime 3, right? Okay, g prime 3 will be 3 times f prime 3 plus f3, correct? Okay, so would be f3 here. So f prime 3 is -2, and f3 is what? f3 is 4. Okay, so this one will give you what? -2. All right, so this one will give you -2. So what is -2 here? We set a derivative at the point here. Remember that it's very important. Derivative at this point, what is this? That we call this the slope, right? Okay, so after you have the slope, after your point, now let's write down the tangent line. So it's y minus 12 is equal to -2, what? X minus 3. So this will be -12 plus 6. So you move the -12 over. So what is your final answer? So y will be -2x plus 18. That will be my tangent lines here. You see here for the both videos, we always practice how to find the tangent lines here, right? Okay, so now this one, the number 10, I really like it. I think this is very good problems and to see whether you understand or not. Okay, so the first thing, so let's take a look at what they want us. They say f prime 2. Okay, so f prime 2, that means I need to take the derivative of p functions, right? Okay, so p is the fx times what? Gx here. Okay, so now I'm going to use the product rule. So holding the first one, so it's f of x. The derivative of the second one, so it's g prime x. That's right. So here, to highlight that, holding this one, take the derivative of the second one. Then plus holding the what? Holding the second one, gx. Take the derivative of f prime x. Right? Okay, so let's say you're holding this one. Okay, so now they're looking for p prime 2. So substitute the x equal to 2. So this is f of the 2, right? So then this is g prime, the 2, plus g2, the f prime, the 2. Okay, so now let's take a look. f2, okay, f function is this purple function, right? So this is 1, so here, so here is my 2's, right? So in the x-axis is 3. So this is 1, 2, 3, 4. That's my y-axis here. Okay, so now let's take a look. The first one's here. Okay, f equal to 2. So f equal to 2. So that means it's equal to 3, right? The function value, I can find it. G equal to 2. What is G equal to 2 here? It's 2, right? So this is my function value. All right, so you just look, you use the graph. So this is here, this is here, right? Okay, so what is G prime, right? G prime, right? That means G prime, the 2, we say is the tangent line at that point. And then now this tangent line, because this is already a function, so this is a tangent line here, right? So it's just like, it's in here. So what is the slope of this line here? This one's here, what is the slope of this line? So it's rise over what? Over runs, right? So it's 1/2. So I know this one is what? 1/2. Okay, let's take a look at f prime 2. F prime 2 is, here's the 2. We know is the slope of the tangent lines here. So what is the tangent line here? Because this is, so the tangent line is here, right? So it's the parallel line, the horizontal line, just touch that one point. So what is the f prime 2 here? F prime 2 is 0, right? So when you add them together, so what is the answer? Is 3/2. The reason I said this problem is a very good problem is because you need to use the graph, and then you can get the, so it really tests your understanding. What is the slope means, right? What is derivative means here? All right, that's it. Okay, so this is the practice set. We did 10 problems. 6 of them are pretty mechanical, and the rest 4 are good problems for the application type of problem. Special number 10, I think, is a very good problem to test your concept of understanding, the slope and the tangent line, those things. All right, that's it. And it's a very useful tools, the product rule, right? And then I'm going to, for next unit, next video, we're going to talk about the quotient rules as another very important the rules here. All right, that's it. I hope that after this video and after practice, you can be very good at it. You have to be very good at it so you'll be able to continue to the next topics here, right? All right, that's it. And you guys have a nice day, and let's, looking forward to talk to you in our next videos here. Okay, bye.